This presentation explains how to build a semantic layer on an AI-ready IT architecture. The objective is to make AI reliable, scalable, and aligned with business meaning. The presentation is structured in two main parts. First, we focus on building the semantic layer, then on designing the IT architecture for AI. The semantic layer is what transforms raw data into AI-driven automation. Without it, AI systems operate blindly on technical structures instead of business meaning. These three KPIs summarize the strategic value of the semantic layer. They highlight its impact on AI quality, financial performance, and company valuation. AI errors are dramatically reduced when models understand business concepts. The semantic layer grounds AI in vocabulary, structure, and real business examples. AI ROI increases when decisions rely on trusted metric and stable semantics. A strong semantic layer enables AI to move beyond experimentations to industrial scales. Companies with mature AI foundations achieve higher valuation multiples. This is driven by predictability, automation leverage, and reduced operational risk. This diagram presents the global architecture of the semantic layer. It shows how business meaning is positioned between data and AI consumption. The semantic layer unifies fragmented and siloed data into a coherent models. It ensures that analytics and AI always interpret data consistently. The Semantic API exposes business meaning while aiding physical data structure. This protects AI agents from technical complexity and schema instability. A simple AI question is transformed into a reliable business answer. This happens through multiple semantic steps with built-in guardrail. This synthesis summarizes how the semantic layer operates as a whole. It acts as a semantic firewall between AI and raw data. The semantic layer can be complemented by an enterprise knowledge graph. This allows tacit knowledge to become explicit, structured, and reusable by AI. TRAIDA AI assistants automate the construction of the semantic layer. They reduce manual effort while preserving modeling discipline. AI-assisted modeling drastically reduces cost on iteration cycles. Experts focus on semantic decision instead of repetitive technical work. The semantic layer is built progressively step by step. Each level improves precision and prepares the next one. The Semantic Processing Unit orchestrates all TRAIDA AI assistants. It behaves like a processor dedicated to semantic intelligence. Each TRAIDA assistant has a specific semantic responsibility. Together, they cover the entire modeling lifecycle. These assistants establish a shared business language for AI. This consistency is essential to avoid hallucinations and misinterpretation. TRAIDA assistants are available as specialized GPTs. They can also be reused manually through shared instruction files. Each assistant is used independently to preserve focus and quality. Outputs are reused step by step across the workflow. The Business Glossary Builder extracts vocabulary from business use cases. It creates a common language shared by business IT and AI. The Business Data Model Builder structures concept and relationship. This forms the semantic backbone of the data architecture. The Glossary Validator checks consistency between terms and models. It eliminates ambiguity and duplicated meaning. The Data Model Validator verifies alignment with real business scenarios. It ensures that all use cases are correctly represented. The Synthetic Data Generator produces realistic example data. This data is used to validate models and train AI safely. The Narrative Generator explains the data model in plain language. It makes semantic structure understandable beyond technical teams. The Logical Data Model Builder transforms semantic into normalized schema. AI never accesses the physical model directly. We now illustrate the approach using a concrete practical case. This example demonstrates the full semantic workflow. These guidelines ensure reliable interaction with AI assistants. They help avoid hallucinations and quality degradation. High-quality use cases are critical for semantic accuracy. They must focus on data meaning rather than processes. This section focuses on business glossary generation. It is the foundation of the entire semantic layer. The glossary can be refined iteratively with the AI. This improves coverage and precision over time. Root packages organize business terms into coherent domains. They structure the future data model. AI may infer additional terms beyond the original use case. These anticipate future business evolutions. The glossary must always be validated by business experts. Human validation remains essential. We now generate the business data model. This step translates vocabulary into structure. Several iterations may be required to reach acceptable quality. AI accelerates the process but does not replace expertise. The generated model is imported using the XMI standard. This ensures tools interoperability. The model is organized into semantic packages. Each package represents a coherent business domain. Packages are visualized and refined independently. This simplifies modeling and review. AI can be used again to improve semantic quality. Manual refinement remains possible at every step. This version shows improved semantic structure. Layout optimization is done manually. About 70% of the model is generated automatically. The remaining 30% requires expert judgment. Each package contains one clearly identified main table. This improves readability and semantic focus. Package origin can be displayed explicitly. This helps navigation and understanding. Cross-package relationships are shown when needed. They preserve global coherence. We now validate the business glossary. Validation ensures semantic consistency. The glossary validator highlights gaps and inconsistencies. It supports semantic governance. This analysis provides detailed feedback. It guides corrections before moving forward. Industry standards are used as neutral references. They improve robustness and interoperability. Validation continues across all glossary elements. The goal is semantic stability. The result is a controlled and unambiguous vocabulary. This is essential for reliable AI. We now validate the business data model. This ensures alignment with reality. The model is checked against actual use case. Missing or weak areas are identified. The validator explains the model to business users. This improves adoption and trust. Business concepts are mapped to data structures. These bridge business and IT perspective. Key business processes are explicitly identified. They encode the model in operations. Industry standards reinforce semantic quality. They reduce interpretation risk. A global assessment summarizes strengths and weaknesses. It supports executive decision-making. We now generate synthetic data. This makes models tangible. Synthetic data validates models with business users. It also trains AI safely. The generator explains what the model represents. This provides business context. Example values are generated for each main table. They illustrate real usage. Linking examples show how records connect. They clarify relationships. A short summary concludes this step. The model is now validated and usable. We now generate business narrative. Narratives make semantic explicit. Narratives help both humans and AI interpret data. They complement formal models. The full model is explained in plain language. This supports understanding. The main table is identified and described. It encodes the narrative. Key attributes are explained from the business perspective. This clarifies meaning. Relationships are summarized clearly. These avoid misinterpretation. All attributes are reviewed for completeness. Nothing essential is missing. The narrative ends with a synthesis. The semantic picture is complete. We now generate the logical data model. This prepare implementations. The logical model follows normalization standard. It ensures data integrity. Each package is refined independently. Quality is improved step by step. Logical model quality depends on semantic clarity. Good semantics lead to good databases. Instructions can be adapted to company standard. This enables long-term autonomy. We now move to IT architecture for AI. Semantics meet infrastructure. The semantic layer becomes the entry point for AI. All systems consume business-aligned data. The IT stack is selected based on scale and governance. Flexibility and security are key. Financial analysis cover CAPEX, OPEX, ROI, and NCO. It supports informed investment decision. The roadmap structures deployment over time. Risk and dependency are made explicit. Thank you for your attention. We invite you to explore this approach in your own context.